All right, welcome to my tutorial on solving and graphing linear inequalities. Let's go ahead and get started. First, you got to remember what inequalities are. Like an equation is two math expressions that are equal to each other. Inequalities are going to represent two expressions that are not equal to each other. And there are a few symbols that we use for inequalities. And here they are. Now, most people represent the words in this manner, but I'm going to tell you that these words are not correct. Really, the first symbol is not greater than, it is greater than. Second symbol is less than. Third symbol is greater than or equal to. And the last symbol is less than or equal to. Now, I can't make the corrections on those words, but we'll be using that in class. So let's take a look at some sixth grade graphing of inequalities that you guys did. So the first example, we have x is greater than 5, and we have a number line. 5 is our endpoint, and so 5 is not part of our solution, because if you substitute 5, is 5 greater than 5? No, 5 is not greater than 5. So we have to exclude the 5 by leaving it as an open circle. So our endpoint is going to be an open circle. Now we have to shade. We have to shade to the right. Why? Because where are the values that are bigger than 5? To the left or to the right of 5? They're going to be to the right. So we shade to the right. The second example is x is less than negative 1. Now, x is less than negative 1, so we substitute negative 1. Is negative 1 less than negative 1? No, it is not. So we need to leave our endpoint as an open circle. Negative 1 is not part of our solution, so we have to exclude it by leaving an open circle. Now we have to shade. Well, where are the values that are less than negative 1? So they're going to be to the left of negative 1 on the number line, so we shade to the left. All right, third example, x is greater than or equal to 3. Now, 3 is our endpoint, so we substitute 3 for x. Is 3 greater than or equal to? Yes, it is. And so what we have to do is we have to include it into our solution set by closing the circle and coloring it in. That means that 3 is part of our solution. Now we got to shade. Are we going to shade to the left or to the right? Well, x is greater than negative 3. So where are the values of x that are going to be greater than negative 3? I'm sorry, positive 3 are going to be to the right. So all the values that are greater than positive 3 are going to be to the right. And the last example, x is less than or equal to 5. Our endpoint is 5. 5 is part of our solution set, so we put a closed circle because if we substitute 5 for x, 5 is less than or equal to 5? Yes, it is. And so we have to do the closed circle. And now we shade. And we shade to the left because the values of x are going to be to the left of positive 5. Now let's go ahead and solve some inequalities. Here we got negative 3z minus 12 is greater than negative 3. Now we're going to continue to use the steps that we did in class, Friend Zone Common Algebra Math Chump, but I'm not going to go ahead and write them out. I'm just going to go ahead and get started because this video will be way too long. So the first step in our steps is to undo our constant of negative 12. How do we undo negative 12? Well, we add 12 to both sides, just like an equation. Same steps. And so on the left-hand side, we end up with negative 3z is greater than positive 9. Now we're going to undo multiplying or dividing a variable term. Z is being multiplied by negative 3, so we've got to divide both sides by negative 3. Negative 3z divided by negative 3 is z. 9 divided by negative 3 is negative 3. And here we get to a point where it's going to be a big difference with equations. Because we are undoing multiplying or dividing by a negative, we have to reverse the inequality symbol. This is a common thing that kids forget to do. Again, when you undo multiplying or dividing by a negative value, you got to reverse the inequalities symbol. Now we have to graph it. Let's make a basic number line. In my class, just use 3 values. We'll always put 0, and we'll put negative 3, which is our endpoint, and the opposite, positive 3. And so, are we going to have an open or closed circle at our endpoint? Well, is negative 3 part of our solution set if we substitute it for z? No, it's not. So it's going to be an open circle because negative 3 is not less than negative 3. It's false. It's a false statement. And now we shade. And we're going to have to shade to the left because the values that are less than negative 3 are going to be to the left. And so that's how we're going to graph in our class. Let's go ahead and do another example. Here we have x divided by negative 5 plus 2 is greater than or equal to 1. Again, follow the steps. Friends, don't come in algebra math chump. First step, we undo adding or subtracting our constant. And so we're going to end up on the left-hand side with x divided by negative 5 is greater than or equal to negative 1. Now we go to undo multiplying or dividing of a variable term. We need to undo dividing by multiplying both sides by the same value, which is negative 5. Negative 5 times x divided by negative 5 is x. On the right-hand side, we end up with positive 5 because negative 1 times negative 5 is a positive, but our symbol, we are undoing multiplying or dividing by negative. So we have to reverse the inequality symbol. Very important step. Hopefully you do it correctly. Now let's go ahead and graph, make our basic number line, and our endpoint is going to be positive 5. Is positive 5 part of our solution? Yes, it is. And so we have to do a closed circle because 5 is included in our solution set. And now where do we got to shade? Well, since x is less than 5, where are the values that are less than 5? On the number line, they're going to be to the left. So we shade just above our number line, and we're going to shade to the left. All right, let's try another example here. Negative 2f minus 6 is greater than 2. Let's go ahead and start and undo our constant by adding 6 to both sides. We end up with negative 2f is greater than positive 8. Undo multiplying or dividing of a variable term. F is being multiplied by negative 2. How do we undo multiplying? By dividing. And what are we going to divide by? Negative 2. We go ahead and end up with f on the left-hand side. On the right-hand side, positive 8 divided by negative 2 is negative 4. And again, we are undoing multiplying or dividing by negative, so we have to reverse the symbol. Now let's graph it. Is negative 4 part of our solution? No, it is not. And because of that, we have to do an open circle. Now we have to shade. Where are the values of f that are less than negative 4? Well, they're going to be to the left of negative 4, so we shade to the left. All right, hopefully I'm not going too fast, but this should be all review from equations. All right, let's do another example. N divided by 2 minus 3 is greater than negative 7. Follow the steps. First thing we have to do is undo adding or subtracting of our constant. We end up with n divided by 2 is greater than negative 4. Now we go to undo multiplying or dividing. N is being divided by positive 2. How do we undo dividing by positive 2? Multiplying both sides by positive 2. On the left-hand side, 2 times n divided by 2 is n. On the right-hand side, negative 4 times positive 2 is negative 8. And here we are undoing multiplying or dividing by a positive. Do we have to reverse the symbol if we undo multiplying or dividing by a positive value? And this answer is no. The inequality stays the same. It is only reversed when you undo multiplying or dividing by a negative value. Now we graph. We're going to graph n is greater than negative 8. Negative 8 is going to be our endpoint. Open or close circle. At our endpoint, negative 8, it's going to be an open circle because negative 8 is not part of our solution. Negative 8 is not greater than negative 8. Now we have to shade. Where are the values? Since n is greater than negative 8, where are the values that are greater than negative 8 on the number line? They're going to be to the right of negative 8 on the number line. So important. You are not undoing multiplying or dividing by negatives, so you keep the inequality symbol the exact same direction. Let's try another example here. 4a plus 10 is greater than 2. Again, follow the steps like equations. Undo adding and subtracting of our constant. We end up with 4a on the left-hand side is greater than 2 minus 10 is negative 8. Undo multiplying or dividing of a variable term. We're going to have to divide both sides by 4 because a is being multiplied by 4. And so on the left-hand side, 4a divided by 4 is a. On the right-hand side, negative 8 divided by positive 4 is negative 2. And we are undoing multiplying or dividing by a positive value. Do we have to reverse the symbol when we undo multiplying or dividing by a positive? The correct answer is no. The inequality is going to stay the same. Again, Again, our variable term is positive, so we're not going to have to undo it once we get to this step right here. All right, let's go ahead and graph a is greater than negative 2. Make a basic number line for my class. A is greater than negative 2. Is negative 2 part of our solution? If we substitute negative 2 for a, do we end up with a true or false statement? And we end up with a false statement because negative 2 is not greater than negative 2. And so negative 2 is not part of our solution, so we put the open circle. Where do we shade? Well, a is greater than negative 2. So where are the values on the number line that are greater than negative 2? They're going to be to the right, so we shade to the right. Now, this was just a quick tutorial. We'll be going over it in class for a few days. If you have any questions, reach out to me. Thanks for watching.